Hello everyone, this is Doug. I want to talk to you briefly about measurements in chemistry, why we care, how we use different measuring devices like graduated cylinders and rulers and balances. But I want to give you a little bit of background first and just the importance of measurements, right? And I always kind of joke around that it's just largely because we need to have an objective reality, that we all need to agree with how big and small and how much things are, right? So what happened in the past, and I'm sure you've heard this before, but it used to be that people used finger widths as a measurement, palm lengths, hand lengths. We, of course, have heard of the foot in the United States, people's feet, actually, people's strides. It'd be like, oh, that's so many stride lengths. You know, go to that oak tree, go north 40 strides, and then east 20 strides, and you'll find a well or something like that. Or people will be like, yeah, you know, I need about like three finger widths of this amount of something. Of course, that's problematic, right? Which is kind of what I was trying with this down here. If you use something like a hand length, then this person's going to say that this black rectangle is about 1.5 hands long, whereas this person down here would say that this is 2 hands long. And so this breaks down really, really quickly if you're trying to talk to people with different sized body parts. It doesn't really make a whole lot of sense. So the way we get around that, right, and you guys probably know this already, and you think that the idea of using body lengths as reliable measurements, the idea is that we use standards, right? So we use a standard for measurement, right? We use a standard. So for example, there's actually a hunk of metal called the kilogram sitting in France, and that is the kilogram. If something has the same amount of mass as that, we call it a kilogram. If it's 1,000th of that mass, we call it a gram. And so there's actually like a kilogram, for example, that we use for masses. In the United States, right, when you buy a ruler, right, we buy rulers. Those are probably the most familiar standards that you're used to. Whether it's 1 foot or 1 yard, you know, there's 1 meters. There are standards that we use. There's a liter. There's all kinds of measurements. There are calories, right? There are degrees Fahrenheit and Celsius. We use standards that are measurable by everyone, right? Everyone agrees that that hunk of metal is a kilogram. Everyone agrees that that length that we now call a foot, sort of ironically, that 12 inches, that's a foot, that's the ruler that we use, right? So if I want to know how big this black rectangle is, I'm going to use a standard to measure it. I'm not going to use hands or feet or strides or anything like that, right? You've all done this before, probably in grade school at some point, but we'd use like a ruler, right? In this case, our ruler is our standard here. So here's our standard that we're using to measure. An important piece of measuring in science, you know, when you use a measuring device like a graduated cylinder or a ruler or something like that, is that you cannot, right? I can't look at this black rectangle and say, oh, okay, I'm going to look at that. I'm going to line it up over here so that it lines up with this rectangle. I look over to where how far it goes on the ruler. So I'm going to say that this is 3.9874209 centimeters long, right? There's no way that your eye can guess that many digits, right? That's a bunch of BS. You can't guess that far. So when you're using rulers, when you're using any measuring device, the idea is that you always guess, you're required to guess one more digit past the gradation marks. And the gradation marks are these lines here, right? So these markings, right? So these markings are sometimes called gradations. And so an important rule here is that when you're making a measurement, right? So whenever you're measuring something, when measuring an object, you always record one more digit past whatever the smallest gradation says. So one more digit past the smallest gradation. So let me tell you what that means. Past the smallest gradation. So if I take a look at this rectangle here, what we're saying is that these gradations, so if I'm using this ruler, my gradations, every single one of these gradations is a decimal point, right? That's 7.1, that's 7.2, whoops, sorry, that's 7.0. Let me go back there. That's 7.0, that's 7.1, that's 7.2. So with this ruler, the gradations, you have some number and it gives you a decimal point in the tenths place. What we're saying is that if you have to guess, if you're going to use this, you are required to guess one more than that. So you are going to have to go to the 100ths place in this case, right? This is going to be your estimated amount. So here we have an estimate. That's what we're going to call the estimated digit, and I'll write that here in a second. So let me take a look at this ruler, right? So definitely to my eye, it looks like this is above 3.9, that black line is above this. All right, so here's my gradation mark, 3.9. To my eye, it doesn't look like it quite gets to the 4. Maybe to your eye it does, to mine it doesn't, but that's why this is an estimated last digit. So if I'm going to record this number, I'm going to say, well, it's 3.9 for sure, right? Because those are the known digits. I can just look at the ruler. I know that it's 3. I know that it's past 0.9. But the unknown one, the one I'm not too sure about, I have to guess. So if I'm looking at this, it's kind of hard to see. I'm going to say that's 3.98. And this we would call the uncertain digit. That last one that you have is the uncertain digit. So just like I said over here, right? Over here on the right, I said that I needed to have the number go out to the 100ths place. And so when I report my number, that 8 is in the 100ths place. And I don't guess any further than that, right? Not like over here where I had a 9 and an 8 and a 2 and a 4 and a 6, right? I can't use all of those numbers. There's no way that your eye can pick those out. I can only use 3.98. And remember that when you're doing any measurement in science, that this number means nothing without the unit. You always need the unit. So if I was to report how long this rectangle is, I wouldn't just say 3.98. I have to say 3.98 centimeters because apparently that's in centimeters. So the numbers that are given by the gradation, once again, are the known numbers. And then the uncertain one is the one that you guess. The one where you kind of say, it's between this and that. I think it's about here. Because this uncertain number is supposed to imply really that you're not 100% sure. It could be plus or minus 1 in that spot. Like maybe this number is really 3.99. Maybe this number is really 3.97. But it's probably in that range, right? It's in that range there. So the number is somewhere around there. And with all measurements that we take like this, right, there's going to be some degree of uncertainty. And we'll have to manage that degree of uncertainty when we talk about significant figures. Just to give you a little preview, I'd say that this number has 3 significant figures because it has the 3, it has the 9, and it has the 8. So that'd be 1 figure, 2, 3. 3 significant figures. And we'll talk about doing math with them later. But let's take a look at some other measurements. So let's say I have this, I'm going to do the bottom one first actually, this object right here, this like gray whatever object, and they color it down here for you too. Once again, right, I have the gradations here. I can very clearly see what the gradations are. I know it's above 11 because there's the 11 mark, so I've got 11. I'll draw this up here. I know it's definitely 11. And again, it looks like all of these gradations are 0.1s, so I get to say, oh, that's 11.1 here, 11.2, 11.3, 11.4. It's not quite to 11.5, right? I don't quite get to 11.5. It's somewhere in between the two. And so I'm going to look at this based on right in the middle of that black line. So I'm going to say this looks to me like 11.46. 11.46. Where again, just like we were talking about before, these first 3 digits, these are all the known ones because the ruler told me for sure that it was past 11 and for sure past 0.4. And then 6 was the one that I guessed and I used my eye, so that's the uncertain digit. And you're always going to want to report that uncertain digit, right? The thing I'm forgetting here is the centimeters. So if I report this as 11.46 centimeters, if you report this to me as 11.4, you're going to lose some credit because your measuring device is more precise than that. I need more information. So you need to have that uncertain digit. If you think that something's exactly on the mark, so like let's say for example, like the case with this screw up top, if you think something's exactly on a mark, and honestly to me this line looks like it's exactly on that 5.1, the 5 and the 1 are very, very clear, and then I'm guessing that that is exactly on the 1, so I put a 0. Right? If you think it's exactly on a gradation mark, put the 0. Don't ignore the 0, because that means that you think that your measurement is less precise than it is, right? 5.10 is different than just saying 5.1. 5.1 has fewer significant figures. It only has 2, whereas 5.10 has more significant figures, right? The more significant figures, the idea is that we have more confidence in our measurement and more precision and more information in that measurement. So if you think it's exactly on a gradation, acknowledge that by putting a 0 at the end of the number. So I'd have 3 significant figures. Another way to remember this, right, like before I was saying, you always need one more digit than the gradations, right? In this case, all of the gradations, right, this is 5.1, 5.2, 5.3. So in this case, you have a number and a decimal point, and then you have to guess that one more. You don't know what that one is. So all your numbers should go out to the 100th place using this ruler. And so that's what I did up here, right? I went out to the 100th place. So you got to just pay attention to what the calibrations are on your measuring device. We can do this with measuring volumes. So here I have a couple of graduated cylinders. We'll do the same exact thing. Graduated cylinders they're basically like rulers on their sides, right? But when we're measuring liquids, you always want to measure from the bottom of the meniscus, right? So measuring volume, we always measure from the bottom of the meniscus. And by meniscus, right, normally in like drawings, whoops, sorry about that. Go away. There we go. When we draw these when we draw the meniscus, right, say this is liquid in a solution, we draw this kind of circly thing where the surface, where you can see the adhesive and cohesive properties of the water that you're looking at. And the idea is at the bottom of the meniscus, right, the meniscus is this thing, that roundy thing. And so what we're saying is you measure from the bottom of it. That's the bottom of the meniscus. And so if I look over at the top liquid here in this graduated cylinder, that's the bottom of that meniscus, and here's the bottom of that meniscus. That's how these pieces of glassware are calibrated. They're calibrated so that you measure from the bottom of the meniscus. Other than that, we treat it the same as if we were measuring length. We just look at what are the units, how many units do I need, and you try to always make sure you have that estimated number, right? So for the first one up here, this is looks like a 10 milliliter graduated cylinder. 10 milliliter graduated cylinder. All of these gradation marks actually look like they're in 2s, right? If you take a close look, because this is probably 7 milliliters right here, 6, 7, 8. So this is 6.2, 6.4, 6.6, 6.8, and 7. So I know that this is definitely above 6.6, and I need to guess what's in between the two, right? So if I look at this, I'm going to say this is 6.6, and it's a touch above that, not quite 6.7, maybe 6.65 milliliters. And that would be my estimation, right? Because again, this goes out to the 1/10th place, so my answer needs to go out to the 1/100th place, right? You always need to go one more digit than the gradations on your measuring device. Now, if I look at the one below, same thing, only it's a sort of a less precise measuring device because this is a 100 milliliter graduated cylinder. And so if you take a look at this, right, all of these gradation marks are in 1s, right? This is 55, this is 56, 57, 58, 59, 60. So all of these gradation marks are in the 1s place as opposed to up above, they're all in the 0.1s place, right? The 10th place. So here I have 51 for sure, 52 for sure. I know it's definitely above 52, right? Because there's the 51 and 52 mark. Not to 53 though. So I need to look at this meniscus and say, well, it's definitely more than 0.5. It looks like it's above that. I'm going to say this is 52.7 milliliters. And again, I added that last uncertain number. It's one more than the gradation marks here. Here the gradation marks went to the ones place. So one more gradation mark would be to the tenths place, which is what I put there. So again, right, we want to measure one more past the gradation. Let me just circle that again without running over it. And that's how we measure volumes. Bottom of the meniscus, just like with using rulers, you always add one more digit than whatever the gradations are telling you. And then recording mass is going to be really straightforward, especially for us because we have all digital scales. Right, it's super easy because if you're measuring using a digital scale, you just record what the scale says. So for digital balances, right, simply record all of the numbers given. Record all of the numbers given. So for this one, super straightforward. It says that this thing is 0.2040 pounds. So that's what I would write. You don't have to really guess anything. It gives you all of the numbers that you're going to use. For some reason, I get students that just feel like, oh, well, I shouldn't use that last 0 and that last 4. That's too small, or that doesn't matter. You always just use all of the numbers that it gives you. Certain balances go out so many digits. Some go out further than others. Just write down everything that you're given. The same rules sort of apply, though, even if you use digital scales. These are still considered the certain measurements, and the digital scale, that last digit, is still the uncertain one, right? It's still considered uncertain. It's still the real value could still be plus or minus 1 from that. Maybe it's really 0.2041, or maybe it's really 0.2039 pounds, but we just assume that last digit has a little uncertainty to it. And again, we'll talk more about how to deal with that uncertainty when we talk more about significant figures. Again, that's just a flash forward, or if you're familiar with significant figures already, right, I'd look at this number and say that it has 4 sig figs, 4 significant figures. And when we do math with them, we need to kind of take into account that uncertainty. And there are crazy ways to take that uncertainty into account, and are really mathematically cumbersome, but in chemistry we just use the significant figure rules, which is much easier and gets you about the same answer anyways. So I hope that kind of gives you an idea of how to measure things in science, chemistry especially, and I recommend that you watch a video now on how to do math with these significant figures. Thank you very much.